Hi everybody, today we are going to be talking about more applications of determinants and matrices, specifically in the form of cryptography. So cryptography is just the process of encoding a message, so it's a secret code, and we can use matrix multiplication to encode and decode these messages. And the other skill that you will also need to be able to do is you will need to be able to find the inverse of a matrix. So take a second and I would write down these values. It's just the alphabet in order and then numbering them, but it'd be nice to have them to reference because we're going to be transferring letters to numbers to create matrices. Okay, so to encode a message, first you will be given a message, and you're going to write each letter as its corresponding number, according to that chart we just looked at, into a matrix with 3 columns. So you go across the rows, and you just fill it in until your matrix is full. So then you're going to take that decoded matrix, or uncoded matrix, and you're going to multiply it by what's called an encoding matrix, which is something that you will be given. And then your remaining numbers, you can write them in a row as a cryptogram. So now it will be coded. So let's give this one a try. So we're going to encode the message, "Meet me Monday," and this is our special encoding message. So the first thing we're going to need to do is write "Meet me Monday" as a matrix. So the idea is we're going to write it in this form. So we're going to fill in our matrix with 3 columns. So meet and then a blank, M-E blank, M-O-N-D-A-Y, and since we have to complete our matrix, we'll put another blank. So we're going to replace each letter with its corresponding number of the alphabet. So it'll be 13, 5, 5, 20, and then our blank is 0. Then 13, 5, that's me, and then 0 for the blank, and then 13, 15, 14, 4, 1, 25, and then we end with our blank. So this is what's called our uncoded matrix. So now we have to code it, we have to put it into our secret form by multiplying it by our encoding matrix, which we are given. And this is where we're going to get a lot of good practice from matrix multiplication. So just to review, remember, in order for us to multiply, the dimensions have to work. So this is a 5 by 3 matrix, and this is a 3 by 3. These two numbers must match, and our resulting matrix will be a 5 by 3. So remember, the process for matrix multiplication is you multiply the corresponding numbers in this row with the corresponding numbers in this column. So we do 13 times 1, and then we do plus 5 times -1 plus 5 times +1, and so that will give us 13. And then we do the same thing with our second column, 13 times -2 plus 5 times 1 plus 5 times -1, which is -26. And then 13 times 2 plus 5 times 3 plus 5 times -4, which will be 21. So we're going to repeat that same process now with this column in with this row in our 3 columns. So that should give you 33, -53, -12. And now we'll do the third row with our 3 columns. So that should give us 18, -23, -42. And now our fourth row with our 3 columns gives us 5, -20, and 56. And then our fifth row with our 3 columns should be -24, 23, 77. So now this is what is called a coded matrix. So these values, if you gave them to a random person, they wouldn't know what they meant. But if you gave them to someone with an encoding matrix, they could decipher them. And then technically you take them and you list it out in a row like this: 13, negative 26, 21, 33, and you list out all your numbers, and this is our cryptogram. So we just created a cryptogram. All right, so now I'm going to have you guys try one on your own. So go ahead and pause the video and give this one a try. So the message is owls are nocturnal, and notice that we have a different encoding matrix. Okay, so first you write your message as an uncoded matrix right here, and then you multiply it by your encoding matrix, and remember, across with down, and these are the values you should get. So you list them off, and that's your cryptogram. So now we're going to talk about, well, how do you decode a matrix? So to decode a matrix, the first thing you have to do is find the decoding matrix. Now this is just going to be the inverse of your encoding matrix. So you do have to be given your encoded matrix in order to find the decoding matrix. And then you're going to multiply your coded matrix by your decoding matrix. And then the remaining numbers will be your uncoded matrix, which then you can match with their corresponding letters to find out what the code is, or what the message is. Okay, so here we're going to decipher this coded cryptogram, and we're going to use this encoding matrix. So the first thing we're going to need to do is find a inverse, because that will be our decoding matrix. So remember, the way that we find an inverse, we create an augmented matrix with our original matrix on the left, and then we put an identity matrix on the right that matches the same dimensions. So our goal is to use Gauss-Jordan to turn the left side of our matrix into our identity matrix, and then whatever's left on the right side will be our inverse matrix, which will also be our decoding matrix. So let's start the process of creating some zeros. So the first thing I'm going to do is I'm going to try to turn these into zeros. So I see that for my second row, if I add row 1 and row 2, I can create a 0 in my first element. And then if I add row 2 and row 3, I can turn this 1 into a 0. So let's do both of those steps at once. So this will become a 0, -1, 5, 1, 1, 0. And then if I add row 2 and row 3, I get a 0, I get a 0, and a -1, and then 0, 1, 1. And make sure you're still you're doing the same process on the right side as well. That identity matrix should be changing. Okay, so now I'm going to try to turn this into a 0, and I see that I can turn that -2 into a 0 by multiplying row 2 by -2 and adding it to row 1. And then I'm also going to multiply row 2 and -3 and row 3 by -1, so I can turn these into positive 1. So let's start with that first one. -2 times 0 plus 1 is 1. -2 times -1 plus -2 is 0. And then here I'll have -10 plus 2 is -8. Here I'll have -2 plus 1 is -1. Then -2 plus 0 is -2, and then 0 plus 0. And then these we're just going to multiply by -1. Okay, so we're almost done, but I see that I still need to turn both of these to zeros. Luckily, once we have double zeros in our bottom row, it's really easy to do because I can add them to any multiple without changing the ones that we've worked so hard to create. So to change this -8 into a 0, I'm going to multiply this by +8 so they cancel out. So we'll do 8 row 3 plus row 1. And to turn this to a 0, I'm going to multiply this by positive 5 and add it to turn that to a 0. So 5 row 3 plus row 2. And we are already happy with our bottom row. Okay, let's do some addition. So we have 1, 0, 0. And then we have 0 plus -1, so -1. And then we'll have 8 plus -8 plus -2 is -10. And then positive 8 plus 0 is 8. Oops, I'm sorry, that should be -8. And then let's add 5 times row 3 plus row 2. So we have 0, 1, 5 plus -5 is 0. And then we have 0 plus -1 is -1. -5 minus 1 is -6. And then we'll have a -5 right here. So since this is now an identity matrix, that means the right side of our matrix, what's remaining, is a inverse, which will also be used as the decoding matrix. So I'm going to now take this code that we were given right here, and I'm going to write it as a coded matrix. So I'm just going to take it and write it in a matrix with 3 columns. So it was 13, -26, 21, 33, -53, -12, 18, -23, -42, 5, -20, 56, and -24, 23, 77. So that this is our coded matrix. And I'm going to multiply it by our decoding matrix, which is that A inverse. So -1, -10, -8, -1, -6, -5, and 0, -1, -1. And then you're going to do a little bit of matrix multiplication. So remember, across the rows, down the columns, and take those sums. And you should end up with 13, 5, 5, 20, 0, 13, 5, 0, 13, 15, 14, 4, 1, 25, 0. Now, if you write these numbers out, so we have 13, 5, 5, 20. They might look a little bit familiar. 0, 13, 5, 0, 13, 15, 14, 4, 1, 25, 0, and you match them with their corresponding letters, you are left with Meet Me Monday. So you have that same message that we had from example 1. So we essentially took our coded matrix that we created and we decoded it. All right, go ahead and pause the video and give this one a try. Start by finding A inverse. Okay, so first start by checking the process of finding A inverse. Your decoding matrix should be -2, -3, 1, -3, -3, 1, and -2, -4, 1. Now, the process that I used might be different than the process that you used, but if you had some trouble along the way, I would say try it with my steps and see if you can get the correct inverse matrix. From there, remember, we take our coded matrix from the code we were given, and we multiply it by our decoding matrix, and we are left with the uncoding matrix, which if you match these numbers with their corresponding letters, it's exactly what you did in your last example. It's owls are nocturnal. All right, that is all for today. Thank you so much for watching.